Hey everyone, today we're going to talk about VPCs or virtual private clouds. I think it's an important topic because it forms an overarching, almost like an umbrella over a lot of the networking concepts you learn when you use Google Cloud or any other cloud provider's infrastructure. Because network acts like the glue between your different virtual machines, your different databases, your instances, and the world in itself. But before we get into VPCs, let's talk about the internet, and in particular, one of the key design principles that has made the internet what it is today. So from a technical perspective, we know the internet obviously consists of your hardware components, so your cabling, your deep sea cabling, your routers, as well as other software-based components like DNS, DHCP, and other configuration protocols that allow all these disparate and separated systems to be able to communicate. And so one really crucial thing that the designers of the internet did was to design the internet in a way that it abstracted away all the complexities that came about with networking, different types of systems, and systems all across the world. And so if we're to visualize the internet, we see that you could have users all over the world, let's say some in Algeria, Portugal, Mongolia, able to interact with each other just by sending simple requests using their web browser to each other. However, underneath the web browser is a gargantuan set of cables, networking, a lot of logic that can enable this to happen. Any user sitting wherever they are has no idea about the underlying networking that ensures that they're able to do all this. And so abstraction is extremely important. So when you're sitting in Portugal, you have very little understanding of exactly how your request got shipped all the way to Mongolia. The way the internet works is your packets would probably hop between different servers, let's say one in Romania, another one in Kazakhstan, before actually heading to Mongolia, where your request can be served. Once again, you as a user may not even know the status of the server or where that server is located. All you know is that you're able to communicate with a person sitting here in Mongolia, and all of that was taken care of you. So abstraction is key. So now that we know that abstraction is a core component behind the internet, we need to think about how do cloud providers leverage this idea and bring it to users of this cloud services. And through this abstraction is where the whole idea of VPCs come in. Let's see what they are. I think the best way to explain what a VPC is to break down each word and how that relates to the whole idea of networking, in particular to the cloud. So the V stands for virtual. And whenever you hear the word virtual within computer science, or let's say technology in general, the whole premise behind that notion is that you're trying to abstract something away from what it actually is. So for instance, whenever you hear the word virtual machine or a VM, the idea behind a virtual machine is that it tries to emulate or simulate a real computer. So the idea of simulation is important. So when we talk about a virtual private cloud or a VPC, what we're trying to go for is something that actually simulates a real network. However, we want that simulation to have real world effect. So let's say I'm within a data center here, let's say in the US West 2 in LA, somewhere around there, and I want to communicate to some other service here in Brazil, in our South America region. I still want my packets to be able to travel all the way down here and have some effect on, let's say it's a database call and I'm trying to update a database. I still want that information to be able to go through there. Another reason why it's also virtual is because Google does not want us as users to have to deal with, once again, the complexities that come with networking. And so they abstract that layer above the actual hardware and software that goes into the complex nature of networks and give us some form of basis or platform to allow us to network in a way that we do not have to think about the underlying infrastructure. It just happens. And that goes back to the design, one of the core designs that made the internet extremely useful and usable across the world. So let's talk about the private component within a virtual private cloud. So let's say you're a user, you have some resources here in London. Google does have a data center in London, in Belgium, in the Netherlands, as well as Finland. You may have a database resource here, you may have a compute resource in Finland, and some other, let's say, machine learning resources in the Netherlands. You have to remember, you're not the only customer using Google Cloud. And what's important is that your communications between your different components do not conflict with other people's communications within their different components. And so communication, therefore, needs to be private. So only your instances, only your resources can be able to communicate given the rules that you set up. You do not want packets having packets from a different company mixing with yours, because that's a big security risk. And so the whole idea of privacy comes in. There's a layer of isolation that's provided between networks in different parts of the world that pertain only to you and your project. And so one of the ways Google enables this privacy between all your components and isolation between different projects and different users is through the use of private networks. And private networks are defined by the use of what are known as private IP addresses that fall underneath the RFC 1918 category. So one key component about private IP addresses is that IP addresses that are private cannot be routed to the public internet. And that's important. So you can have all your organization's communications happen within a defined or demarcated location. So if you have, let's say, a database in London and some compute in Finland, through the use of private IP addresses, you have a network that is closed off to the rest of the internet. And that's brilliant when it comes to privacy. Cloud providers will also ensure that there is a level of encryption within your network such that users are not able to see what is being communicated on these channels. So imagine you're developing an app and your front-end servers sit in Finland over here. And the entire backbone of your infrastructure is spread across Europe. And it could be for various reasons. It could be legislation or close access to certain resources, whatever your business has decided. The beauty about private IP addresses is that within this entire section over here, it's closed off to you and your organization. So these components can communicate the way they want, and as well as with their instance in Finland. And so in Finland, you can have an external or public-facing IP address, let's say a 34.123.whatever.something, and this is what the rest of the world can see. So if a user is sitting here in Ukraine and they want to be able to log into some resource that you have, they can just point towards this IP address, and all your instances within that network, I'll just call this a network, are able to communicate, and ingress and egress only happen through this Finland public IP address. So you have isolated everything within a network and only opened one gate to public communication. And that's brilliant when it comes to security and other forms of security risks. And so cloud providers are tasked with ensuring isolation and security within their VPCs. Remember, the internet is a public-facing network. And so anybody, anywhere, has the ability to attack or view or do anything malicious with the data that passes their system. So if you have a user here in Barcelona, and they're using the public internet to be able to transfer information here to Rome, if the packets hop to different spots across the world, let's say Paris, Vienna, before coming back to Rome, they can easily be intercepted or read, let's say the encryption is not good, between these two destinations. And obviously the internet's getting better at that. However, all this is happening within a public domain that you have no control over. Within a VPC, you have control over all the communication that's happening within a predefined network. And that's very important in ensuring security and privacy. And so the last portion of VPC is the cloud. All the communication and everything that's happening within these networks that are part of your VPC are happening within a cloud and are managed by a cloud provider. So each cloud provider, like AWS or Microsoft Azure or Google Cloud, all have the ability in catering a certain product to users with regards to VPC. And so Google may say, hey, we offer this type of encryption that's more secure, or we offer virtual LAN services and other managed connectivity services. So Google also ensures that the resources such as networking meet a certain SLA. So the uptime could be 99.99%. And for an organization, that's very important. You want your instances to always be able to communicate. And if anything goes down, Google has a very experienced team of SREs and other technical experts who can actually go and solve the problem for you. So another core offering Google may provide may be flexibility and scale. And you may have the ability to control your different workloads, move different instances from different networks. So for example, once again in Europe, if you had some resources here in London, other resources in the Netherlands, and let's say a database here in Finland, a cloud provider can enable you to be able to move instances in and out these different locations and modify the network such that traffic can flow in whatever way you want. And so further offerings like firewall rules can determine in what direction packets can flow and where they can't go. So these are just different offerings that cloud providers within Google can provide. And there you have it. So I think this is a good place for us to end. We've been able to put together all three parts of the definition for virtual private cloud, and I hope I've been able to at least explain the essentials to VPC. In the next section in this two-part series, we'll do a deep dive into the components that make up a VPC. So if you guys found this video informative, please feel free to subscribe or like the video. I highly appreciate that, and I'll see you next time.